Hello everyone. Welcome to this advanced introduction to the technological aspects of the free and open source software model. In this training, you're going to be provided with a basic introduction to the technological aspects of open source development model and a more advanced discussion of the technologies that underpin them and the different methodologies for building and maintaining an open source software, hardware or data project. You will also understand some of the basic principles and rules on how to contribute to open source software, hardware and data, and you will understand differences between the three categories. This module is designed for beginners who are curious about the way open source software, open hardware and open data works. Participants may also wish to know, but also to participants who may wish to know more about the way open source development works in practice, the tools that are being used, and also some tips and tricks on how to run a successful open source software, hardware, or data project. Upon completion, we expect you to be able to understand and explain the main elements of open source projects, to explain different approaches to software, hardware, and data projects, and describe the basic technologies that contribute to the functioning of open source as a geographically distributed development model. In terms of topics, we're going to be covering four main topics. Namely, building and deploying open source projects, how to contribute to an open source project, open hardware projects, and open data projects, which provide some specific and very interesting use cases. Now, in terms of building and deploying open source projects, there are some foundation technologies that you must be familiar with. So when it comes to building and deploying, there are a few phases that you need to consider, but the key can be summarized by what you see on this slide. So, for example, you first need to start with solid planning and foundation, following a problem solution approach, followed by a development and workflow using technologies such as version control, strict adherence to contribution guidelines, and thorough code review. Then at the stage of deployment and maintenance, you must have a strong development strategy, community management approaches, and so on and so forth. And then finally, we're going to be discussing some of the tools, and both technical and organizational, that are essential when building and deploying open source projects. So in terms of planning and foundation, it's important to follow these 5 steps. So first, you must identify a clear problem, then be able to provide a solution and clearly identify your project goals and target audience. Secondly, you must be able to choose an appropriate open source license using informed advice. It does not necessarily have to be an advice given by a lawyer, but it should be well informed by how communities understand and interpret the different terms of the popular open source licenses such as MIT or GPL. Then you must organize your code, documentation, and resources in a way that is clear, modular, and user-friendly. And then you must also invest, very importantly, in good documentation, such as README files, tutorials, guides, and so on and so forth, to help users understand and also to engage them in future contributions to your project. And then, of course, you have to start. And you have to start building a community early on, by encouraging discussion and welcoming contributions from practically anyone across the world. And when it comes to setting up a development and workflow, you must first establish some of the unwritten rules, because as discussed in the basic module to this training, the unwritten rules in open source communities play far greater role compared to any written rules. There is a certain code of conduct that community members adhere to, and by building a new community, when building a new community, you should also have such unwritten rules that people would accept and follow over time as your project matures and evolves. So you must very importantly set up a workflow that utilizes version control system like Git, for instance, to manage code changes and collaboration. You must very importantly set up automated testing and use continuous integration and continuous delivery for efficient builds and deployments, you must use a platform like GitHub to track issues, bugs, pages, and also to communicate with the communities when it comes to raising either technical, organizational, legal, or ethical challenges relating to your project. You must also create very clear guidelines for contributing code, documentation, and other work. And you must, of course, maintain a high quality throughout code reviews, static analysis, and unit testing. When it comes to deployment and maintenance, again, here you must follow at least the following 5 principles. So first, utilizing the version control system, setting up clear guidelines, maintaining high code quality through reviews or static analysis or unit testing. So this is equally applicable. When it comes to some of the tools and resources, you can see here a list of some of the popular platforms such as GitHub or GitLab, which are the 2 most popular platforms around the world for hosting open source code repositories and collaboration. And you can also, and you should, get in touch with organizations and explore the resources and information they provide on open source licenses and best practices. And just a few examples of these organizations here include Free Software Foundation and its sister organization, the Free Software Foundation Europe, the Open Source Initiative, Linux Foundation, which provides excellent additional training courses that can enrich your knowledge in open source, including open source compliance, for example, and of course, the Software Freedom Conservancy. How do you contribute to an open source project? So let's assume you've identified a project that you like and you would like to contribute to it. What are the main guidelines and rules that you should follow when considering contributing to an open source project? Well, first of all, you must find a project, and before you start coding, you should establish certain you should have certain familiarity with the tools you're going to be needing, and then also you must craft your contribution by considering deployment strategy, community management, also learning how to create a pull request and other technical means. And then you must follow some general etiquette rules and additional resources and guides. So first of all, how do you find a project that you may wish to contribute to? Well, you have to choose wisely. So you must align your interests and skills with the project's needs. You should be looking for active projects with well-oriented contribution guidelines. You should always start small. So consider beginner-friendly issues or bug fixes before tackling some more complex tasks. And of course, you should do your research. So for example, first read the documentation that's already available, community discussions, what are the expectations from new contributors, and so on. Sources. Similarly, when you're crafting your contribution, you should always make sure to follow the style guide. So this means adhere to the project's coding conventions and documentation formats. So be sure to familiarize yourself with this documentation. Importantly, and that's also part of any good developer's workflow, you should write clean and efficient code. So ensure that your code is well commented, easy to understand, and adheres to best practices. And of course, you should also always test your changes to make sure that you do not break existing functionalities and you do not create regressions. And there always should be, your code should always be well documented. So you should write clear comments and follow the rules of the community you're contributing to. So when creating a pull request, for example, some shorthand rules, you should always use a descriptive title. So briefly summarize your changes and link to relevant issue. provide some details such as explaining your approach to the problem, reasoning, any deviations from the typical project standards for contributors. Attach screenshots or GIFs, for instance, if your changes somehow affect the user interface of an application or visuals. So visual aid is always helpful when your code involves such changes. And you should always remain open to feedback, respond to reviewers' comments promptly, and always address their concerns constructively. This is part of the spirit of open source communities. And some general rules of etiquette that you should follow when contributing to open source projects. So first and foremost, you must be respectful, meaning maintain a positive and polite tone in all communications. Acknowledge contributions of others, so always thank reviewers and community members for their support. Document your process by sharing your learning and challenges to also help others contribute. And you must always remain patient. These open source projects, after all, rely on volunteers. So understand that responses sometimes may take time. Provided here a list of some guidelines that already exist out there. So for instance, one of the most popular is the GitHub guideline for repository contributors. And we have also examples of the guide for contributing to the freecodecamp.org community. And there are, of course, many more. Some large projects adopt guidelines, independent guidelines for contributors. So if you're contributing to such a project, always make sure that your contributions are aligned with the requirements of these clients. Now, we would also like to focus on some specifics when it comes to open hardware projects and open data projects. So for open hardware projects, the same principled workflow applies, but you should understand that contributing to an open hardware project, mostly because it involves building actual real things, involves a slightly different approach and requires a slightly different perspective. So for example, when you're seeking to find an open hardware project, you should always make sure to look for projects with active forums. So meaning open design files or clear contribution guidelines, because there are many open hardware projects that are not under active development, and you obviously do not want to get involved with a project like that unless you want to revive it and start building new. You should always consider online platforms that exist already, such as Hackaday, Open Hardware Repository, and Thingiverse to discover new projects that are being actively maintained. You should search for projects aligned with your skill set, whether it's mechanical design, whether it's circuit design, 3D printing, or simply providing contributions to documentation. It's very important to understand the hardware workflow, which is fundamentally different to that of open source software. So you must always make sure to familiarize yourself with the project's bill of materials, schematics, mechanical drawings, and so on and so forth. Understand the design tools that are being used and software that's used by the project, such as KeyCard, for instance, or Fusion 360, and many other tool chains. And you should always make sure that you're comfortable collaborating on physical prototypes, because, as I already mentioned, open hardware projects involve building things, material, real, physical things. So you must be comfortable with collaborating over physical prototypes. In terms of contribution options, you could always contribute to an open hardware project in very many different ways, such as, for instance, design improvements, or by modifying existing designs, optimizing for manufacturability, or offering alternative design solutions. You could also be making documentation contributions, such as improving assembly instructions, or creating tutorials, or translating existing documentation. Valuable and valid contributions to open hardware projects are, of course, contributions relating to testing and feedback. So, for example, by building prototypes or testing functionality and providing detailed feedback to improve the project, you would be making a significant contribution to the open hardware communities. Similarly, competent sourcing is an important aspect of contributing. So this may involve things like suggesting alternative components with better availability or cost effectiveness, which is always an issue for any hardware project. And then finally, contributions in terms of tooling and fabrication are also equally valid contributions, and they involve typically proposing improved manufacturing methods or offering expertise in specific deployments and environments. Now, in terms of the specifics for your contribution, you would typically be looking at contribution of 3D printing files, or electronic schematics and layouts, or firmware contributions, which are very important, or testing and documentation, or indeed communication contributions, meaning clear explanations of your modifications, reasoning, and potential benefits to the project. So all of these, you should always consider specific approaches depending on the type of contribution you're doing. But these are just some examples of the types of contributions you could be doing to an open hardware project. Now, for additional resources, we would advise you to check out these two websites. So first is contributing to open hardware makers, and the second is the Open Hardware License Guide, which is a recommended resource. Now, similarly, for open data projects, there are specifics which, in terms of finding a project, involve identifying the type of open data project that exists out there. So for example, we have things like the Kaggle datasets, where you may be looking for datasets that need cleaning or analysis or visualization, which are, again, equally valid contributions to open data projects. You could be looking at research data repositories, where you could be exploring projects that need data management, annotation, or analysis support. You could be looking at community forums and discussions to identify projects that seek specific contributions. Or indeed, you could explore the biggest, as of yet, repository of open source machine learning models, Hugging Face, to explore open access machine learning models and datasets, and identify areas where your contributions might be useful. Very importantly, for an open data project, and indeed for any data project, is to first read the documentation and metadata, which would help you understand the data you're dealing with, grasping the data format, collection methods, and certain limitations. As a second step, you should explore existing visualizations and analysis, or understanding past contributions and project goals. You should also consider joining community discussion forums to ask questions or clarify other concerns that may exist around the project. In terms of contribution options, open data project offer a vast menu of contribution options, such as data cleaning and validation, or enrichment of data, or data analysis and visualization, documentation and metadata improvement, tool development and integration, and of course advocacy and outreach, because non-technical contribution and non-technical contributions in an open data project could make a whole lot of a difference compared to many other projects which are in the software, for example, or hardware domain, which are typically much more feasible compared to open data projects. So advocacy and outreach is a much needed type of contribution in open data projects. And then when it comes to the specific modalities of your contribution, you should of course consider different approaches as to how to do these. How to approach, for example, data cleaning and validation, the analysis and visualization. That, of course, depends to a great extent on the scope and needs of the data project. So you should always consult with the community what types of contributions are most appropriate to the project. And So thank you very much for joining this session on advanced introduction to the technological aspects of open source. Please consult the additional reading materials that we have provided as part of this course. Thank you for your attention. We look forward to meeting you again soon in the future.
Thank you.